Hey guys, my name is Trevor Sullivan. I'm a solutions architect with Stratus Grid, and I'm also an AWS ambassador. And welcome back to the Stratus Grid video channel. The topic for today's video is going to be on a capability or feature of Amazon Elastic Container Service known as AWS FireLens. And essentially, what FireLens is it's a mechanism that allows you to forward logs from your ECS container based applications to some alternative storage mechanisms. Now, if you're familiar with ECS, you probably already know that using ECS, you can have an application just forward logs directly to Amazon CloudWatch Logs service. And you can do that by using the AWS Logs driver. However, there is another driver called the FireLens driver that allows us to use a log forwarding agent, which is going to be either FluentD or FluentBit, which are both log forwarding agents. And what those agents will do is forward your application logs from your application containers to alternative destinations, such as AWS partner solutions like Splunk, for example, or you can even send data to things like Kinesis Firehose or an Amazon S3 bucket or alternative locations. So what this allows you to do is to not be restricted just to using CloudWatch logs as a log storage and querying service, but it opens up the door to a lot of alternative options as well. Now, the way that FireLens works in essence is that it creates what's called a sidecar container. When you create a task definition in the Elastic Container Service, you can define one or more application containers. Typically, you would just have a single container, which is your application container that you want to launch. But when you activate FireLens, it actually creates a second sidecar container. And that sidecar container is what's going to be running the FluentD or FluentBit agent. And that is going to have some very basic configuration that determines where to send your application logs to. So we're going to take a look at how to set up a really contrived example of this, and you're going to see how that sidecar container gets created automatically for you in ECS. Now, before we get started with the actual demo on this AWS FireLens capability, I just wanted to briefly talk about StratusGrid. So StratusGrid has a SaaS or software as a service solution called Stratosphere, which is available at stratosphere.app. And essentially what Stratosphere allows you to do is get visibility and take action on a variety of cost optimization recommendations. So for starters, what we do is we onboard all of your different cloud data sources, which could include multiple AWS organizations. If you're a large enterprise, you may have acquisitions that are happening. And so you might be managing several different AWS organizations all at the same time. And you might also have Microsoft Azure environments that you're also running. Again, maybe you've got certain development teams that are using Microsoft Azure for strategic reasons, or perhaps you have mergers and acquisitions that are already leveraging Microsoft Azure. So you kind of just bring those Azure environments under your umbrella. So what you can do is actually onboard multiple AWS organizations and Azure or Entra tenants into your operating organization here inside of Stratosphere. And then there's a couple of different views. There's a summary dashboard view. There's an advanced analysis view that allows you to get a high-level reporting across your entire cloud environment on different services that you're using, or you can group it by account or group it by which cloud service provider you're using, like AWS or Azure. And this helps you to really narrow down where your spend is going based on service. You can also sort by ascending or descending to see which services have the most usage in your environment. You can also see what discounts are being applied, like compute savings plans in AWS or private rate cards that you might have negotiated with AWS, or a private purchase agreement, also known as formerly a EDP, enterprise discount plan, with AWS. And then you can also see what your potential savings is. And the potential savings is broken out into low, medium, and high level of effort items. So the low effort items are your low hanging fruit. Those are the easy things to resolve and are typically going to net you the most savings. But as you go up to medium and higher level effort items, those may also net additional savings just with additional engineering effort. And then if you navigate over to the findings view here, this is a granular view on a per resource level across all of your cloud environments on what resources you can take action on. So if you have an idle RDS instance here that's not actively doing anything and it's simply costing you money, then you may want to go eliminate that. And we even tell you what the potential savings is for each of those resources. And then you can also change the status. So if you go out and actually delete one of these instances or maybe resize it to something smaller, you can edit the status here and you can say, hey, I've resolved this item, and say, add a comment and say, I've resized this to a smaller RDS instance type, and change the status there. So this helps you to kind of keep track of all of your cost savings opportunities across your cloud environment. And you can also add additional filters here to see specific types of findings. So if you're just wanting to narrow down to RDS idle instances across your environment, you can filter down to that. You can save that filter as a custom filter name for future reference, just to make it really easy to open up again in the future. And so there's a lot of advanced reporting capabilities that you have here inside of Stratosphere. So if you are interested in seeing a demo of Stratosphere, or if you're interested in trialing it, feel free to reach out to us on our website at stratusgrid.com, and we would love to chat with you about Stratosphere. So let's go ahead and jump back into our topic, which is, again, going to be AWS FireLens here. And so what we're going to be doing is actually going into our ECS service here in a live AWS account, and we are going to set up a task definition that uses the FireLens configuration to send data to an alternative location. So as you can see, before we actually go ahead and configure one from scratch, I did just want to show you one that I already have running here. So I've got a singular task running here. It's just a standalone task. So if that task were to exit for any reason, then it would not automatically restart because it doesn't have a service controller corresponding to it, but it is just sitting out there running actively, and there's really no reason for it to crash at this point. But what you can see is if I go to the logs tab right here, I can choose the logs from either container. So I have my log router, which is running the FluentBit container, or FluentD, I can't remember which one it is. And then we also have my application container, which is just a PowerShell script that's running down here. And because that's not using the AWS logs driver, I can't select it right here. This view only allows me to see the logs from CloudWatch logs directly. But what this log router is doing is it's actually taking the application logs from my PowerShell script, and it's actually sending those to an Amazon S3 location. What I can do is head over to the Amazon S3 console over here, and let me filter my buckets here for FireLens. You'll see I've got this bucket here called Trevor SG ECS FireLens. And then you can see there is a key prefix here. So we've got FluentBit logs. And then if we drill into that, we can see my application container right there and the task ID. And then we've got the year, month, day, and then we've got hour and minute. And basically for every minute here, I have these S3 objects, which are basically just text files containing the raw JSON logs. So I can take any one of these S3 objects and then download it. And then I can go ahead and open up that item into a text editor here. So let me open this with, let's say, Notepad. And as you can see, we've got our raw JSON logs here. Now, in this case, this PowerShell script is simply spitting out a bunch of GUIDs. So what it does every, I think, 800 milliseconds is it spits out a new globally unique identifier right here. So in the log text, all you're going to see is a new random GUID being generated. And that's the output from the script, right? So that output could more logically be perhaps HTTP logs from Nginx or Apache web servers or things of that nature, or your custom application logs. So the log text right here would actually be what your application is spitting out, which could be in any format that you want. but it's telling us which container ID it's coming from. It's telling us that it's coming from the PowerShell container here, which is just a name or identifier that I set up when I created the task definition. But this is what the logs actually look like inside of Amazon S3, rather than having ECS directly send these to CloudWatch logs. So even though back in the ECS console, we could see that the Fluent Bit container, the sidecar container, was in fact sending its logs to CloudWatch logs. My actual application logs are being sent over to S3 using this log router container as a sort of proxy. So the log router is taking the output from my application container and it's sending it over to Amazon S3, but then Fluent Bit itself also has some output, and that is simply going to CloudWatch logs. And it's basically just logging a new entry here every time that it uploads a new log file for my application logs into my Amazon S3 bucket. So let's go ahead and take a look at how we actually set this up from scratch. So we're going to kind of rewind. We've already taken a look at an example here of how it actually works in practice, but how did we get to this point? That's what we're going to take a look at now. So what you'll want to have for starters is an Amazon VPC. So if we head over to the VPC console here, you're going to want to have a VPC that has a public subnet and internet gateway with the route table set up for your subnet to go out to that internet gateway. So I've already got a VPC here that has several different public subnets here. I think I've got, one in each availability zone. So I've got one in 2D, one in 2C, 2B, and 2A. And I've also got some other private subnets here, but we're just going to ignore those. We're just going to use these public subnets for now because we are going to provision our ECS task into one of those public subnets. And that will ensure that our ECS task has the necessary routing out to the internet to actually pull the necessary container images from remote container registries when we launch our ECS task in Fargate. So you'll want to have a VPC set up. If you don't have one, you can always go to the VPC dashboard here, and you can use the Create VPC wizard here. And this will allow you to specify how many public subnets you want, how many private subnets you want. If you want a NAT gateway so that you can run tasks in private subnets, that's an optional thing that you do have to pay for, hence the little $ there. So this helps you to just set up a simple VPC with subnets and routing tables really quickly, and your internet gateway and all that fun stuff. So feel free to use that wizard to set up your VPC. And then the other thing that we are going to need to create as a prerequisite is something called a task role. So in Amazon Elastic Container Service, when you run a task or run an application inside of a container in ECS, whether it's Fargate or EC2, you can have an application identity called an IAM role that's bound to your application task. And then that role determines what permissions to AWS APIs your application actually has. So in order for FireLens to work, we need to make sure that FireLens has permission to the destination where we want to send the logs to. And we also need to make sure that we have permission to CloudWatch APIs, CloudWatch logs specifically APIs, so that the log router sidecar container can publish its logs to CloudWatch logs, and then also be able to forward the application container logs over to your destination of choice. So what we're going to do is create a new IAM role here. We're going to use the trusted entity of the Elastic Container Service right here. And then we're going to choose that this is a task role. So this allows ECS tasks to call AWS APIs on your behalf. And then I'm going to attach S3 full access right here. You could create a more granular policy that gives access only to a specific S3 bucket, but I'm just going to choose S3 full access for the sake of simplicity in this video. And then we're also going to enable the CloudWatch full access v2 policy here as well. And what we're going to do is give this role a name. So I'll call it Trevor SG YouTube AWS FireLens ECS. And then we'll go ahead and create that role. I'm also going to add the owner tag here just so my teammates know in this development account that that is a role that I've created. Okay, so now we have the IAM role. It has S3 full access, and it also has CloudWatch full access. And these are the only permissions that our application is going to need in order to send logs to CloudWatch logs and send logs to Amazon S3. Also, because of the template we selected, the AWS service template for the task role, there is a trust policy set up here for the ECS tasks service to assume this role. And so this trust policy here is what allows the ECS service to actually use this role as a task role. So if this trust policy or trust relationship is not set up correctly, then you won't be able to see this role when we actually go to deploy the ECS task. All right, so the next thing we need to do is head over to the Elastic Container Service here. So you can just search for container up here, go over to ECS, and you're going to want to have a cluster set up. So typically what you do is you go to create cluster, say Trevor ECS FireLens YouTube, and then you can choose for infrastructure here. You can say, I want to use AWS Fargate for this, and then you can add optional resource tags down here as well. So I'll go ahead and just add that. And then you'll just hit create cluster. And when you create a cluster in ECS of the Fargate type, it doesn't deploy any infrastructure because Fargate is totally serverless. It doesn't actually provision any compute capacity until you actually deploy a task to your cluster. So when you create a cluster for Fargate, it's just kind of this logical entity that you are creating. It's not actually creating any virtual machines or anything like that. So now we've got this cluster here set up, and of course there are no tasks running on it because we just set it up. We could also go over to configuration here, and if we go to update cluster, we can add a capacity provider and say I want to use Fargate Spot, which is a discounted version of Fargate that allows you to use spare capacity with no guarantee that that capacity will actually be available. You could also add Fargate as a backup provider as well. So we'll allow us to use both of those. And then what we're going to do is create a task definition. And the task definition is what defines the application container that we actually want to deploy into ECS and a whole bunch of other parameters. So I want to show you how we're going to deploy a sample workload. So rather than building a custom container image and hosting that inside of the Elastic Container Registry or ECR service, that requires some additional setup because if with a private registry, we have to have another IAM role that has permission to access that private registry. So what I'm actually going to do is write a very simple PowerShell script that just generates random data, just like we saw in the logs where it's just generating these random GUIDs and spitting them out into the logs. And we're going to just use the stock PowerShell or .NET container image from Microsoft, and we're going to then take a script and embed it directly into the Docker command that's used to actually launch the container. So it's going to be perhaps a little bit confusing if you've never done this before, but what we're going to do is write a very simple PowerShell script. So what it's going to do is going to be a while loop. So while true, so while infinity, it's never going to break unless it crashes for some reason, like out of memory error or something of that nature, or if we explicitly break out of this loop, which we're not going to do. But we're just going to say start sleep milliseconds. We'll say maybe 500 milliseconds. So every 500 milliseconds, I want to do something. And what do I want to do? Well, I want to write host. And then the object I want to write is going to be generating new app log. We'll put a placeholder and then use the .NET-F operator here. And this will allow us to use substitution to use this placeholder and substitute it for some value. So I'll just do new GUID.GUID. And so that will replace a GUID with this placeholder right here. And we'll just have this static text as a prefix. So basically every 500 milliseconds, our PowerShell script is going to spit out this context here into our application logs. And if we were to run this, inside of a PowerShell session, this is what the output is going to look like. So I'm just running the script locally to verify that it actually works correctly. And now what we can do is take this entire script, it's only 4 lines, but we're going to package it up as a single base 64 encoded string. And then what we can do is pass in this parameter to the PowerShell process called -encoded command, and we can simply paste the base64 encoded command, the script, into that parameter, and that will launch that script in a PowerShell process. So there is a helper website out there called base64encode.org. And so what we're going to do is paste our script into that website, and then we're going to choose for the encoding here that we want to use UTF-16LE, little endian. So that's very important. You have to choose UTF-16LE, otherwise it will not encode correctly. Then you just click on the encode button, and this string here is our script that has been base64 encoded using the UTF-16LE, little endian character set. So this script here, or this string here, is our script as a single string. So now what we can do to test it locally, again, is just to do PowerShell -encoded command and then paste in this string here, and we should get exactly the same output. So now what we're going to do is take this PowerShell command that we built right here, and we are going to pass that into an ECS container. And we're going to use the official Microsoft.NET core image, which also includes PowerShell pre-installed into it, in order to run this application container. So that's going to be our kind of made up, very contrived application that spits out some logs. So I'll call this Trevor SG-YouTube-FireLens-demo. And then for our infrastructure here, we're going to be deploying it with Fargate, so we'll leave that there. For the CPU, I'm going to bump it down to 0.25 vCPU, and then we'll give it half a gig of memory, which should be enough for this particular application here because it's pretty lightweight. And then for our task role here, this is where we're going to choose the IAM role that we just created and gave permission to the S3 and CloudWatch services. So we're going to choose that role. And so now our application containers, including our log router that we're going to configure in just a second, are going to have the necessary permissions to call the necessary CloudWatch logs APIs and the necessary S3 APIs, put object in particular, in order to write our logs. Now for container number 1 down here, this is our application container. So you can call this whatever you want. I'm just going to call it Posh, PWSH for short, or you could call it PowerShell, or you could call it MyApp01. You can call it whatever you want to. That's just a unique identifier for that specific container inside of the overall task definition. And the reason it has to be unique is because a task definition, again, can have more than one container. And we are going to have more than one container because the log router, Fluentbit, is actually going to get configured as a sidecar or secondary container inside the same task definition. Now, if you go out and search for the PowerShell docs for Docker, you'll be able to find the official reference to the Microsoft container image here, which is mcr.microsoft.com/.net/SDK. And then there is a latest tag, or you can pin it to a specific version of the .NET runtime, but this actually has PowerShell pre-installed into it as well. They used to have a separate PowerShell container image. It used to be mcr.microsoft.com/PowerShell, but they have since updated this documentation earlier this year, I think, or maybe late in 2024 or something like that, to actually use the .NET image instead of a separate PowerShell image. So this is the image that we're going to be using from the Microsoft Container Registry in order to run our sample script. So that's going to be our image URI right there. And again, latest is implied if you don't specify the tag for the version of the container that you want to run, but I'm just going to be explicit there. I can also remove the port mappings here. We don't have any inbound listeners, so we're not listening like a web server or anything like that. We're literally just having a background application, a background service that just generates logs to standard output. So I don't need any inbound port mapping, so I'll go ahead and just remove the default port mapping for port 80. If you did have a web server or something like that, you'd probably have port 80 or port 443 or some custom port opened up there. But because I don't have any listeners for this application and it's just generating random log data, I don't need any inbound access. Okay, so now we're going to go down to the logging section here, and we're still under the section for container number 1, which is my application. So there's a lot of different a lot of different configuration that goes on here. Before we actually get to the logging, let me go ahead and actually set up the PowerShell command. So under Docker configuration down here, we're going to go to the command section, and this is going to be basically overriding the entry point for our application container. So we're going to call PowerShell, comma, dash encoded command, make sure that's typed exactly, comma, and then we're going to go ahead and paste in the base64 encoded script. So you should have posh, comma, dash encoded command, comma, then the base64 encoded script, and that is the entire payload that we're going to be launching inside of the context of the .NET SDK container image. And of course, PowerShell is pre-installed, so calling that binary name is going to work. All right, so now let's go ahead and go back to the logging stuff here. By default, under the log collection settings here, it has Amazon CloudWatch selected. So you can just give it a CloudWatch log group that you want it to use to write logs. You can tell it what region that log group should be in. You can give it a stream prefix as well for all the individual log streams underneath that log group. You can tell it that you want it to create the log group if it doesn't already exist, assuming that your IAM role has permission to do that. You can give it a buffer size and a mode here as well. But if you click on this drop-down box, you actually have a bunch more options here. So AWS FireLens allows you to send to Kinesis Firehose. You can send to a Kinesis stream. You can also send to an OpenSearch cluster. You can also send to Amazon S3, that's the one we're going to use, or you can export logs to a custom destination. And if you use custom destination, you're going to have to look up the documentation for the corresponding partner solution. Like if you're going to use Splunk or something, there's a built-in one for that here. But if you're going to use another custom destination, you'll have to look up the documentation for that to figure out how it works. But if you choose one of these templates up here, like S3, for example, then you will see most of these parameters are already filled out for you. So we're already operating in US West 2 Oregon up here. So it's pre-populated the region. It has the file size here for our log. So it's saying cap the files at 1 megabyte. It's giving an upload timeout of 1 minute here. It says use put object for S3. That's turned on. So the only thing that we have to specify here is what is the name of the S3 bucket where we want to store the application logs. And so what we're going to do is go back over to the S3 service. So I'll middle click that to open it up in a new tab, go over there, and I'll find the S3 bucket that I've already created. So if you're following along with this video, you'll just want to create a new bucket or pick one of the buckets that you have in your environment, and you'll be able to use that as your target. And then the key prefix here will be automatically built based off of the container name, FireLens, and then you're going to also have the task ID here as well from ECS. So let's go ahead and just paste in that bucket name right here. And that's pretty much all we have to do. And because we chose export logs to S3 via AWS FireLens, check out what happens. When we scroll down, we now have this log routing container that did not exist before called FireLens. And so down here, it's going to pre-populate all this stuff for us. It's going to use the public ECR registry. So Amazon Web Services has their own thing called ECR public. So in your account, you can use ECR private repositories, but you can actually create a public repository and host container images on their public ECR service as well. So they have a public container image that does not require any authentication for FluentBit right here. So it pre-populates that. It's marked as an essential container. So if for some reason something crashes inside of this log router FluentBit process, then that will terminate your entire ECS task. And if you have a service controller set up, then it will start up a new one for you. But by marking it as an essential container, if that container exits or terminates for any reason, then your entire task and all the other containers that are defined in the task definition are also going to get terminated. It doesn't have any inbound port mappings because it doesn't have any listeners. All it's doing is capturing the logs from your application container. We don't really have to customize anything else here, but you're going to see under log collection here that, again, the log router itself, so the Fluent bit process that's running in its own separate container from your application container, the Fluent bit container is going to be sending its logs to CloudWatch Logs. But your application container is going to have its logs captured by this log router container that is a sidecar as part of the same task definition. So we have one task definition with two different containers, your application and the log router, which is FireLens. And then FireLens is going to log its logs to its CloudWatch log group, and your application logs are going to get sent to S3 based on the bucket that you specified here, thanks to the FireLens integration. So I think that is everything we really need to set up here. I also like to add tags, so I'll just do an owner tag of Trevor Sullivan. And when you actually deploy a task from this task definition, you can take any tags that are defined at the task definition level and propagate them to the task itself. So that saves you having to define them at the task level as well, duplicating those tags. So now that we've created this task definition, we can now go ahead and deploy a standalone task. So we'll say deploy, run a task. What's the desired number of tasks? We just want one for now. Choose a cluster. So this is where we're going to choose the kind of virtual cluster objects that we created. Our capacity providers, we've already defined at the cluster level. So it's Fargate, Spot, and Fargate. And then down here for networking, we're going to choose our custom VPC here. So if you used the VPC dashboard to create a VPC like we talked about earlier in this video, you want to choose that and then click on clear current selection and then just check off the subnets that you explicitly want to use. I'm going to skip over my IPv6 only ones because I'm not sure if it'll work with those. So I'm just going to choose my standard public 1, 2, 3, and number 4 down here, that's US West 2D. This one is IPv6 only as well. These ones are private here. This one's IPv6 only, and that one's IPv6 only. So I'm only choosing the public subnets that at least have support for IPv4 and possibly also IPv6. Okay, for security groups down here, this doesn't really matter, again, because we're not accepting any inbound connections. So the security group allowing inbound access to ports is not really relevant. So I'll just use the default security group there. Don't really need that, but it's there anyway. Public IP, I'm going to have that turned on because I am deploying to a public subnet. And in order to route out to the internet, I need to have a public IP address since I don't have a NAT gateway set up and only have an internet gateway. For the tags down here, I'm going to say propagate the tags from the task definition. So when I create the task resource from the task definition, it's going to take the tags from the task definition and apply those to the task as well. So then we'll just go ahead and click on the create button and deploy the task. So then back under the ECS console here, you'll go to your clusters, get rid of those notifications there. You're going to find your cluster that you created here. Go over to the tasks tab, and it'll take a moment here for it to provision, but you'll see that you have a new GUID generated. That's going to be your task ID, D054, et cetera, et cetera. And if you open that up and then take a look at the configuration here, you can see we've got a quarter of a virtual CPU and ½ GB of RAM. We are using Fargate Spot. We are deploying an AWS VPC. It has a public IP, IPv4 address, I should say, and it should be using the task definition that we created just a moment ago. And then you should also see under details down here, you should see the configuration for the container here. And then you can actually see we have two different containers in the same task because there's two different containers in the task definition. So when you deploy a task, both of those containers get deployed. So for our log router, go to log configuration. You can see that's configured to send to CloudWatch. And then your application is what's configured to use FireLens. And it's targeted at this bucket here that we've already pre-created. So if we just kind of refresh here, eventually these containers should change into the running state. It takes a moment for them to get started because the Fargate service has to find the necessary compute capacity. It has to download the container images and extract them on the local server that is kind of opaque from the customer view in Fargate, and then it has to start up both of those containers. So now both containers are actually running. And if we go over to the logs tab here, you're going to see what we saw before in the sample that I showed you earlier. So now we have the log router that is sending its data to, or its logs to a CloudWatch logs group. And we could go over to the CloudWatch log console and view that separately if we wanted to, but we can just see it right here in the ECS console. And then my app01, that is the application container that we defined running the PowerShell script. So in order to see the logs for that my app01 container, we have to go back over into Amazon S3. So we'll come back over here into S3, into our bucket here called FireLens, and you're going to drill into the FluentBit logs prefix. That's just a standardized prefix. And now we have two different prefixes showing up under there. We now have myapp01, FireLens, and then D054, et cetera, et cetera. That is the new task ID that was allocated to our Fargate container. Then we get to year, month, day, hour, and then minute. And you're going to see these text files start to show up here. So now if we download this text file and open it up inside of a notepad editor here, you should see the logs like what we defined in our script that we base64 encoded. So it should say something like generating new app log and then some random GUID, right? So if we turn off word wrap here and we just scroll down a little bit, check it out. We have all these entries here saying generating new app log, and then it's generating a new GUID, generating new app log, new GUID, et cetera, et cetera, et cetera. So every 500 milliseconds, it's generating that new data. And if you scroll down through the logs here, you're just going to see that repeat over and over inside of our application logs. So it's really easy to configure FireLens. The main things are that you have to go out, pre-create your S3 bucket if you're going to use S3 as the destination, or if you're going to use Kinesis or Kinesis Firehose as your destination, you want to go pre-create those resources. You want to also make sure that your IAM role that is set up for your task role in your task definition settings, you want to make sure that that has the necessary permissions, policy permissions in IAM to call the necessary APIs on the service that you are sending your application logs to with AWS FireLens. In this case, it's S3, but again, it could be Kinesis Firehose, could be a Kinesis Stream, could be Splunk that has its own configuration with an API key and things like that. But for AWS services, you want to make sure that the IAM role, the task role, has permission to all those destination services. And you also want to make sure it has access to CloudWatch logs so that the log router itself, the FluentBit container image, can send its logs to CloudWatch logs. So in any case, it's pretty easy to set up FireLens. You just set it up in your task definition, you deploy out your task, you make sure you have that task role associated with it, and then your log router container here, sidecar container, that's part of the same task, is going to ingest your application logs and send them off to that alternative destination. So I hope this video has been educational for you and that you've learned something new from it. Please leave a like on this video, subscribe to our channel, and leave a comment down below if you did learn something new from this video. And as always, we would love to hear your feedback. So thanks so much for watching, and we will see you guys in the next video. Take care.